Okay, finding the area between the curve and the x-axis. So we're going to integrate this equation with respect to x. So I need to write that. That's how we do the area. And we're going to figure this out from 3 to 6. Okay, so that's step 1. You need to be able to write an integration statement. Okay, now do the antiderivative. So go up a degree, so x squared divide. Go up a degree, divide. Okay, remember you can always check with your brain. Does this make that when I derive this? Do I get that, right? And we're going to do this from 3 to 6. Okay, plug in 6. Okay, so on this question, I am getting a negative. Okay, so here's why I'm getting a negative answer, is because if I draw you a sketch of what this parabola looks like, right? This is a parabola. And if I'm talking about from 3 to 6, this is the area that I'm talking about. And that area is located where? It's in the negative y zone. It's below the axis. So really the area is 81. The negative is just representing that that area just ended up below the axis instead of on top of it. Okay? So we'll just say the area is 81, understanding that the negative is just where that area is located. Okay, number 2, find the area bounded by this and the x-axis. So I'm going to integrate this equation with respect to x. But this time, the question didn't give me boundaries. Okay, so we're going to have to figure out the boundaries ourselves. So when I hit the x-axis, all I need to know is where does this equation, where does it equal 0? So where does this equation equal 0? So I'm going to factor by doing a what kind of method of factoring? GCF. So I drew this for you so you can have an understanding of what's going on. If I was to draw this parabola, this is what it would look like. Then I'm trying to figure out the area from the curve to the x-axis that gets the bounded shape. So you can see that it now goes from a 0 to a 6. Okay, so I'm going to write that in my bounds. Okay, so now I'm going to do the antiderivative. So go up a degree, divide. Go up a degree, divide. Okay, then apply the boundaries. So you're going to do that from 0 to 6. So plug in a 6, subtract, plug in a 0. Okay, if it's all right with you, I'm just going to completely X that right off because that will just be 0. Okay, let's jump here to number 4. Find the area bounded between the x-axis and this curve. So I need to know, where does this curve hit the x-axis? So where does this curve hit the x-axis? Okay, because I need my boundary numbers. So I'm going to kind of do the same process here. I'm going to GCF. I'm just switching sides here so I don't have to deal with negatives. Okay, I'm going to take a 3x out of this one, right? 3x out. X minus 3. So that's where it is bounded by 0 and 3. Now we're going to integrate this equation with respect to x.
How do you know which one's at the top?
Like these numbers?
Yeah.
It's always the lowest, like a range. If you did yours flipped around of what I did it, your answer would just be negative or positive of mine. Like if I get a positive 15, you would get a negative 15. Okay, so we're gonna do the antiderivative of it. So go up, squared, and divide. Up, divide. Okay, again, this is nice. When I plug in the 0, there would really be nothing there. Did you get 13.5? Okay, and if you want to see what this would look like, this is a parabola that's downward. So I kind of have the idea of what the parabola looks like. And then from 0 to 3, this little area right there is 13.5.
My calculator gave me a fraction answer. You believe that it was like
Yeah, that's fine. But you should have a button that switches, like here or something. Like that. Do you have a button that does that?
Yeah.
It doesn't matter. Did it switch it?
Yeah.
Okay, next type. So this one is the area between two curves. Okay, so here's the visual. Cubic, x cubed. Do you know what shape a cube makes? Okay, a cube is an n. And what's the x-intercept of this one? 0. Oh, but it's tripled. So what happens to a triple root? What flattens? So it's going to be a cubic that flattens. And what shape is 16x? What shape does that make on a graph? A line? So it makes a line. So this is what you're doing. You're figuring out the area between them. So this and this, you're trying to figure out how much area is stuck between them. Okay, so you don't have to draw every time, but I'm trying to make you get some connections here. Actually, I do make you draw something on the test, so kind of understand your basic shapes. Okay, so what I need to do is I need to figure out where they intersect. So where does this equation equal this equation? So where does this equation equal this equation? What do you do to solve that? Equals 0, yep. You have to have an equals 0. Then I can GCF. Then I can DOS. Does it make sense on the visual that I drew? This would be a -4, 0, 4. That's where all the intersections are happening. Okay, so here's what we need to do. We're going to integrate from -4 to 0. Oh, sorry. -4 to 0. Which area minus which area? Should you do the line minus the curve or the curve minus the line? Which one would have more area under it? The line has more area than the curve. If I'm talking about between the axis and the line. So the line minus the curve. And then, I wish I had more room to right beside here, I would add, I'm going to add, I don't have room beside, but hopefully you do. I'm going to add what? I'm going to do the area between 0 and 4. Okay, specifically on this one, would we agree that it would be symmetric? This area should equal this area, right? Anybody see that? Okay, so I'm not going to do these both. I'm going to do one of them, and then I'm just going to double it, if you're okay with that. Would that make sense to you? This area would equal this area. So I'm just going to do one of these, and then we'll double it. Okay, so up a degree is squared. 16 divided by the 2 is 8. Up a degree is a 4. The original 1 divided by 4. Plug in a 4. Subtract, plug in a 0. So I got 64. So this area in this zone is 64. By the way, if we had done this properly, it would have came out as negative 64, just because it's below the axis. But we would treat it as an area of 64 as well. So 128 would be the area. Okay, so again, if you get a negative, it just means its area is below the axis, but treat it like a 64, not a negative 64. Okay, we'll do one more. Okay, between this curve and this line. So I know this stuff. I know x squared looks like a parabola. I know this is a what? A line with what kind of property on it? Y-intercept of 12. Okay, so there's my kind of general understanding. So I want the area that's enclosed between them, so I need their intersections. So where does this equation equal this equation? Okay, if you have anything like this, you need to equal 0, right? We're pros at this. Simple trinomials. So that's what I'm doing, from -2 to 6. What's the area between these two graphs? Okay, does this make sense, what you're going to be doing? Okay, so now we have to set it up. Okay, so the integral from -2 to 6. What do you want to do minus what do you want to do? Which one has more area to start with under it? The line or the curve? The line has more area. It's 4x plus 12. Subtract the area under the curve. So this is what I'm doing, by the way. The area under the line minus the area under the curve gets me the middle chunk, right? Does that make sense? That's what I'm doing. Okay, I'm just going to pause here because this is a mistake people make. Okay, it's okay if you do it the wrong order. Your answer will come out negative, and that's fine. You just change it, right? But if I did it the wrong way and I did the curve minus the line, if I did that, the curve minus the line, this is wrong. What's the common easy mistake to make? What did I do wrong? The curve minus the line. You would need brackets, which would carry like that. Okay? And it's okay if you do it. Your answer, let's say the area is 20, you would just get a negative 20 when you come out. Okay? But this would be the problem that people make when they're doing the subtraction. You got to subtract, distribute the subtract. Okay, which we didn't have to worry about because we were just subtracting one item. Okay, go ahead. Give me the antiderivative. So go up, divide. Okay, this whole thing you're going to have to plug a 6 into, and then you're going to have to also plug a negative 2 into.